The final question on the Intermediate Maths Challenge 2026 was about Zoe's unusual swimming schedule. So Zoe had an unusual method of choosing when to go swimming. At the beginning of the year, she randomly chose 3 different days of the week to go swimming and swims only on those days. Using this method, what is the probability that her schedule includes more than or equal to the 3 or more days in a row without her swimming? So as you start to kind of think through this question, what you probably notice is this is going to be tricky, because if we choose like Monday or Tuesday, Thursday, Friday, for example, well, with the fact that we've got Saturday, Sunday, and Monday, like cycling round here, so that's what's making this question tricky. So we need to consider the week as a cycle. And this is just one way to represent it. Or maybe she doesn't swim Monday, Tuesday, Wednesday. And then in which case she could swim, for example, Thursday, Friday, Saturday. That would be one way of doing it. She could actually have 4 consecutive days without swimming. Firstly, how many different selections are there that she could make from the 7 days of the week? That's going to be the denominator of our probability, the total number of options. So let's just say number of possibilities where 3 days no swim plus the number of options where there's 4 days no swim, divided by the total number of possibilities. So if we swim 3 days back to back, that means that we have our 4 consecutive days. And you can imagine here us moving those 3 days around this cycle. Let's do it in a different color. So it could be Monday, Tuesday, Wednesday, or she could swim Tuesday, Wednesday, Thursday, or Wednesday, Thursday, Friday, Saturday, or Friday, Saturday, Sunday, or Saturday, Sunday, Monday. And you can just count these. We just treat these 3 as like the 3 days that we're swimming. They have to be together. We just move them around one place each time. There's going to be 7 options in total, 1 for each day of the week. The number of possibilities where she goes 4 days without swimming is going to be 7. So put a 7 there, okay? What about the number of times where she goes, the number of possibilities where she goes 3 days without swimming? So we don't want to include the ones where she's gone 4 days without swimming, because we've already counted them. So that means we know if she goes 3 days without swimming, so for example, Monday, Friday, and Saturday, and she goes Tuesday, Wednesday, Thursday without swimming, these 3 days need to be bounded on either side with a day where she goes swimming. If we're saying, okay, Tuesday, Wednesday, Thursday, she's not swimming, she has to swim on Monday and Friday. And then there's 2 options for her last remaining day of swimming. And again, we can kind of use this strategy of moving around our cycle here, one step at a time. So here she swims Monday, Friday, Saturday, or she swims Monday, Friday, Sunday. Then we move the days that she doesn't swim around one. Now she swims on Tuesday and Saturday. We go Wednesday, Thursday, Friday, no swimming. And then she can swim on Sunday or Monday. And that's 2 more possibilities. We keep moving one step around this cycle until we've moved 7 times before we start counting the same options again. And for each of those 7 options, we have 2 choices. Here, of course, it's Monday or Sunday for our last swimming day. Again, these 2 parts move around with the 3 consecutive days without swimming, because it has to be bounded on either side. With each of those 7 rotations, there's 2 possibilities. So in total, there's 14. So our numerator here is 7 plus 14, 21. Now we need to count the total number of possibilities. So if we have a choice of 7 days and we're choosing 3 of the days for her to go swimming, we are choosing 3 from 7. You might know a formula to do this. If you don't worry. There's 7 choices for the first day, but then we can't choose that day again. There's 6 choices for the second day, and then there's 5 choices for the third day. But that's not all, because what if we chose Monday, Tuesday, Wednesday, and then we chose Wednesday, Tuesday, Monday? That counts both of these. And there's 6 different ways of choosing the same 3 options, because you could choose them in 6 different orders. It's 3 factorial, in case you're wondering. So that's what we divide by. We divide by 6. So in total, there's 7 times 5, or 35 different ways of choosing 3 days out of 7. So our denominator is 35. 14 and 7 is 21. Divided by 35, we've got a common factor of 7, so it simplifies to 3/5.